Alright guys, so this video is going to talk briefly about how to find the area of what we call sectors and arc length. If you're not comfortable with finding the area of a circle or the circumference of a circle, please see a previous video that I have posted that reviews those topics. But a sector of a circle, as it says in our note sheet here, is going to be a part of the area of the circle. So while our area formula will easily give us the area of this entire circle, what I'm really focusing my attention on here is how do I find the area of that portion of the circle? And so what we have to know in order to do that is a sector is a region formed by two radii. So that means that that angle right there that's formed from the two radii ends up being a central angle. And what's great about a central angle, as we've talked about, is that central angles are equal to their arc measure, meaning not the arc length, but the arc measure. There's 360 degrees in a circle, so 120, for example, that ends up being approximately 1/3 of the circle, or actually that's exactly 1/3 of the circle. So really what I'm asking you to do in this question is to tell me what the area of the circle is, but only 1/3 of the area of the circle. And so, again, one way to think about this is as follows. If this entire circle right here, okay, has an area of 10. And then let's say I draw another circle, the same exact circle, but I simply just want you to find this part right here, that angle representing 90 degrees. That's just simply going to be 1/4 of the entire area. So that ends up being 1/4 the area. But why is it 1/4? Well, it's 1/4 because we know that what that looks like, but the reason actually has to do with its central angle. Since the central angle is 90, and I know that a circle has 360 degrees in its complete in a complete revolution, 90 over 360 is actually the reason why we actually would label this as a 1/4. And so that leads over to the area officially here. When you want to find the area of a sector, you are always going to find the area of the circle still. That doesn't change, okay? So that's area of a circle. But what you have to add or I should say multiply in addition to that is what part of the area do you want? And so you're going to take M, which represents your central angle. So I'll write that here as well. Your central angle is what you're going to do to figure this out. And so that's all you need to know. To find the area of a sector, you not only need your radius, but you need to know your central angle. And so we're going to skip over this proportion part and jump right down into how we would find this area. So I know to find the area of the entire circle, it's going to be pi r squared. So pi times 5 squared. But because I want to find the area of this 120, I instead now want to multiply that area. So this is the area of the full thing. I want to multiply it by 120 over 360. That represents what percentage or fraction part I want of the area. And so this is going to give me my area of a sector, which I'll just call AS to abbreviate, okay? So 120 over 360, well, as I said before, that simplifies to just 1/3. So the area of the sector is just going to be 1/3. 5 squared, well, we know that is 25, and we still have to multiply by pi. I just switched the orders around there. We're allowed to do that. If I want an exact answer, okay, I'm just going to multiply the numbers together and not the pi, because the pi is going to be an irrational number. And so if we want an exact answer, 25 times 3 is just going to be the improper fraction 25/3, and I'll leave the pi in. Now, if I wanted to get an approximate answer with no pi involved, I'm simply just going to do that in my calculator. So if we go to our calculator, we would do 25/3, and actually I'll use the fraction shortcut here instead, 25/3, and then we'll multiply that by pi. That's going to give me an approximation then of 26.2. 26.2 would be the approximate area of this. Now, if you weren't sure that that was accurate, remember that the area of the entire circle was 25 pi. 25 pi was 78.53. Take a look at those two numbers right there. If I take my answer and I multiply it by 3, I end up getting the same exact thing. So that's the reason why this works. So essentially the area of a sector is the area of a circle but then I'm just going to multiply by the central angle that I'm working with here. Arc length, the second half of this, works really the same exact way. So another way to measure the arc is to find its length. So we're not talking about the arc measure anymore. There's 360 degrees always total in a circle for that. Arc length, I'm actually talking about the physical length in a unit like centimeters, inches, or something like that. And so arc length is a fraction of a circle's circumference. Those are the key words right there. Arc length is a fractional part of your circumference. So like the area of a sector, we're going to do the same exact thing. Arc length is just going to be a fractional portion of your entire circumference. And again, we're going to skip over this. So if I want to find this arc length right here, again, using the pizza equivalent, it's basically like I want to figure out how much crust this part of the pizza has, okay? And so when I go down here, what's the length of the minor arc form? So I, again, want to figure out, and let me grab my highlighter here, I want to know this length. Well, I know that the circumference, the entire circle, is just going to be 2 times pi r. And we know the r, of course, is 3, so I would just go ahead and say that it's 2 pi times 3. But because I don't want the entire arc length, I only want 45 3/60ths of it, because 360 is the entire thing. So 45 over 360 is actually what I'm going to multiply in front of this. Now 45 over 360, we know that better as 1/8 when you simplify it. So really I'm just taking 1/8 of my circumference. So now we have the ability to go ahead and calculate this. Again, going with an exact answer, I'm going to multiply 3 times 2, which is 6, and 6 times 1/8 is going to be 6/8. But we know 6/8 is better known as 3/4. So the exact answer is going to be 3/4 pi. That's the entire arc length of this portion of the circle. Now, what is 3/4 pi going to be as a decimal? Well, we're just going to go ahead and enter that in our calculator. And so when we do that, we're going to get an approximate answer to the nearest 10th of 2.4, whatever units we're working with here. No units were described. So either of these answers would be applicable here. On the next page, there are a few problems here. So just to give you a few directions on how you're going to do this, the top here is really simply just asking you to find what the central angle is that you're working with and what is your radius. And in all 4 of these problems, that is going to be provided. So you don't have to search for those things. It will give those for you. So we have the 90, we have the 12. That's going to be then my central angle, and my radius is going to be 12. Take a moment now to pause this video and try these 4 problems out. Once you have finished, play the video, and I'll have solutions. Now at this point, you should have finished the 4 problems, and if you still haven't, make sure you pause the video. But what I'm going to do is provide the solutions to these 4 problems to show you so that you can check your work for accuracy. So here's a take a look. We're going to take a look at number 1 first, and I'm going to move that up just so that those goes into focus a little bit better. And I'm going to cover that just for now. So my work is over here. Now I have provided in my work area the exact answer, but also the approximate answer, so that you have an idea. So there's my area. I'm taking 90 3/60ths, which is just 1/4. So it's 1/4 the area. There's my area times 1/4. 36 pi is my exact answer. If you went and got an approximate answer, that will be 113.1. Down here, you can see that there's my work for arc length. So we're going to take 2 times 12 times pi. That's this whole circumference. And again, I'm going to do 90 3/60ths of it, which is just 1/4 of the circle. So 1/4 of my circumference, 1/4 times 24, gives me 6 pi. I'm going to reveal the next 2 solutions here, so please take a look down here. Number 3 is a little tricky, so be careful with that. Number 3, right here and right here, notice I got fractions. So 210 3/60ths, I guess we'll call it, ends up being 7/12 when you simplify it. 7/12 times 16, well, that doesn't come out too pretty. When I simplify it, it ends up being 28/3. And again, there is your decimal approximation if you're looking for that as well. And last but not least, here is number 4. And so once you have finished watching this video, and once you have finished these 4 problems, please look below on Canvas for your next assignment.